All right, so ellipses. An ellipse is a conic section. That's a curve that's created by the intersection of a cone with a plane. Um, and the geometric definition of an ellipse is it's the locus of all points, the sum of whose distances from two foci are equal. So if you take that definition um, and um, work out the math so that um, you figure out all the points that would be equal to, or the sum of whose distances would, to two foci would be equal, what you get is um, the standard form of an equation for the ellipse. There's a general form: x squared over uh, a squared plus y squared over b squared equals 1. Um, and this assumes that the ellipse is centered on the origin. But then if it's not, then you get the standard form where it's shifted um, to where the center is HK. Um, H. So if the center is something that's not the origin, it's the points HK, then the equation would be something like this. So here's the standard form equation for a horizontal ellipse, where the major axis is um, horizontal. And here's a slightly modified standard form equation for a vertical ellipse, where the major axis is vertical like that. The difference is that you switch the A's and B's. All right. So okay. So what does all this mean? We got x. So let's focus on the horizontal ellipse and kind of want to point out what each piece really means in terms of the geometry of the ellipse. So we've got x minus h squared over a squared plus y minus k squared over b squared equals 1. Um, all right, well, x and y are just x and y. This is on a coordinate plane, right? So a point somewhere on the coordinate plane would be x, y. Okay. Um, a squared. Okay, what is a? A represents the distance from the center of the ellipse to the vertices, to each of the vertices. So um, uh, the vertices of the ellipse are these points here where there's the greatest curvature. Um, and the major axis goes from um, one of the vertices to the other. Okay, so A is that distance from the center to a, a vertex. So the major axis has a length 2A. Okay, B squared. Okay, so B represents the distance from the center to the what are they called? Semi-vertices. These points that are closest to the center. Um, the two closest points on the ellipse to the center. Okay, so these are the two farthest points where the distance um, is the greatest to the center, um, and these are the two closest points. So B is the distance from the center to the closest points. Um, Now, C, which is not part of the equation, is the distance from the center to a focus. Uh, so the distance between the foci is 2c. But the relationship between a, b, and c is b squared equals a squared minus c squared. So you might actually start, if you're trying to write an equation for ellipse, you might actually only know a and c from the graph, but a, b, and c form a certain relationship. So you can use a and c to calculate what b is, and then b is actually what goes in the equation. So this is how those quantities relate. Okay, and then HK again is the coordinates of the center of the ellipse. So x minus h, shifts the ellipse over by h to get its the x coordinate of the center over to h, and y minus k shifts it up. Um, so that the center moves away from the origin to H. Okay. All right, so that's what all the pieces mean. Just be careful if you're dealing with a vertical ellipse like this. A and B are swapped around, so it's x minus h squared over b squared plus y minus k squared over a squared equals 1. Um, because a is that distance from the center to the to one of the vertices, right? So 2a is that distance of the major axis. So when it's a vertical ellipse, the major axis is vertical. All right, there is the standard form of the equation for an ellipse and what A, B, and C mean. And I hope you have fun with ellipses. See you later.